Hello guys, what's up? This is Teacher Nikoy, and today we'll discuss about the hyperbola. So there's a question here. Did you know that the orbit of a spacecraft can sometimes be a hyperbola? But always remember, it's only sometimes. A spacecraft can use the gravity of a planet to alter its path and propel it at high speed away from the planet and back out into a space using a technique called gravitational slingshot. Okay, so just like in this image, so if this is an aircraft, they will speed this up. And how come they will have that direction? Because the this planet is pulling them into the into its core. That's why it will swing like that, and it will alter its, what you call that, alter its path. Okay, so it happens that the path of the spacecraft is a hyperbola. So definition: a hyperbola is two curves that are like infinite bows. So do you know what a bow looks like? So we will research that. Bow. Okay, so this is a bow, archery bow. So are one of your classmates join the archery club? Okay, so there are bows like that. Okay, so two bows okay, so here we have an example here. So looking at just one of the curves, any point P is closer to F than to G by some constant amount. Okay, so to the other curve is a mirror image and is closer to G than F. So okay, we have point F here and point G. Then P is closer to F and G is also farther from, okay, G and G is closer to G than F. Okay, I don't. In other words, the distance from P to F is way less than the distance P to G by some constant amount. And for other curves, P to G is always less than P to F by the constant amount. Okay, so point P to F minus point P to G. Okay, so if we minus that and we do the absolute value, so there's no negative, it is always a constant. So this one minus this one, uh, and it will always be a constant. Okay, so PF is the distance. Okay, so G absolute value, so you know absolute value, right? So if there's negative 3 with an absolute value, it will always be 3. So if there's 3, it is still 3. Okay, so no negative value. So each bow is called a branch. So this is a branch, and F and G are called focus. So these two are focus. Okay, so have try it yourself. Okay, so we'll go back here. So you can see the point is here. Look at this. Look at the distance between G and F. Alright, so you can see it is constant, no? P to F is not a constant because it depends on how far, or the distance between F and P. But the distance between G and F is always what? Always the same as here. But you can see that, right? Still the same. It's, even if I put it here at the minimum and put it at the maximum, still, okay, still it is a constant. Okay, then we'll here try moving out P. What do you notice above the length? Okay, so what do you notice if we pull out P? The length of P and F and PG, it is increasing or sometimes decreasing, right? Like right here. So it decrease and increase, then everything on the other branch. So we put it there, so it just what alternates the F and G. Then also some interesting things too. Okay, so you can see this is the hyperbola with the labels on it. So set it smaller. So this one is the, what happened to this? This one is the, this one is the vertex, and this one also is the vertex. So it will be called V1 and V2. You can alternate them. I don't care as long as what's inside is not mm, is not is still the same. Okay. So asymptote. So what is an asymptote? We have here two asymptotes which are not part of the hyperbola but show where the curve would go if continued indefinitely in each of other four directions. Okay, so you can see that it will never touch the parabola. Okay, it will never touch the parabola, but it will only guide the parabola. So this one is a parabola and this one is also a parabola, so that's why it is called hyperbola. Okay, so the distance between two vertices here, an axis symmetry. Okay, so it goes through the focus. So this should be the axis of symmetry. So focus 1 to focus G, or focus F to focus G. Then this is the axis of symmetry. What is the axis of symmetry here? Alright, correct. It is x-axis. Very good. Okay. Two vertices where each curve makes its sharpest turn. Okay, this is the sharpest turn here. So if we have an example, which is the sharpest turn, of course, this one, right? Never mind that. It looks creepy. Then the distance between the vertices 2A on the diagram is the constant difference between P and F. The distance between the vertices, okay, so this distance, this 2A, is the constant difference between the point. So if there's a point here, so the difference between them, that is the 2A. So if there's a point here, so if we subtract these lines, two of them, it will equal to this one, 2A. Okay, then two asymptotes which are now, okay, we already talked about that. And strictly speaking, there is also another axis of symmetry that goes down the middle and separates two branches of the hyperbola. Okay, another axis. Okay, so this is the one he is saying about. This is another axis of symmetry that goes down the middle. Okay, so it is on the middle. Yeah, middle, and separates. So it separates the two parabola. Okay, so we have here the conic section. So you remember this one, right? If you have that one, you cut that, then you will get the hyperbola. Okay. Okay. So this one is the equation of the hyperbola. Okay. So I think there are only two hyperbolas. So you will we'll still have this one, square over a square minus y k square over b square equals to 1. So this one, this 2, is being used if what? The center is not in the origin. So here, this one, this center here is in the origin. So center is 0, 0. Here, this one, the center would be what? The center would be H and K. Okay, very good. Okay, one vertex is at A0 and the other is at negative a 0. So this one is the other one, then that one is the other one. Okay, then so this is plus a, then minus a. So you can see that there, right? Minus a and plus a to the what? H. It depends of what axis of symmetry. So here the axis of symmetry is x, so we get h plus a, then h minus a. Okay, okay, get that. Then after that we have the asymptotes. So this is the asymptotes of are the straight lines. So these are the asymptotes, straight lines. So this is their formula: y equals to b over a x, and the other one is we'll just put negative there. So there are two of them. So negative plus negative b over a times x. So this is for the x-axis, major axis. How about if it will be the minor axis? I mean if y is the major axis, so x equals to what happens? What happens? So are they gonna change? Hmm? No, because if b should always stays in the what? This b is stays at the minor axis, so it will still be the same. B over a x. So a should be the major axis and b should be the minor axis. Always remember that. So we can so it will be easy to manipulate this one. Okay, what happened? Why is it? It's supposed to be y. Okay. So similar. Okay, so there's a note here. So this is the what is this equation? It is for the right, for the ellipse. Now we just change it to from positive to negative. It will become the hyperbola. Okay, very good. So eccentricity, so how curve, where the distance from any point. Okay, so this is the eccentricity. Huh? You see that from the directrix. Okay, so you still have directrix here. So you remember directrix. Okay, so directrix is from this point to is equal to this point over here. So the distance from the vertex to the focus is equals to the distance from the vertex to the directrix. Okay. Okay. So ratio and eccentricity, bam, bam, bam. See, so shows how uncurvy. Okay, so never mind that. P is a point on the curve, F is the focus, and N is the. Okay, so here we have a formula. So this one will go up to there. Okay. Eccentricity is equals to square root of a square plus b square over a. So okay, so we have that. For eccentricity, we have already a formula. Then we have here the Latus Rectum. So you only need the length. So this is here. That is the Latus Rectum, but we have no coordinates. We can only get the what we call this, the length. So as you can see, okay, you can only get the length. So Latus Rectum equals to 2b square over a. Okay, so there's so many we will what you call that we will memorize for lot for the hyperbola. So reciprocally function is y equals 2 is a hyperbola. So 1 over x is a hyperbola. So do you know why 1 over x is like this? Hmm? Do you know why? Okay, so I will explain to you why, because 1 over 2, okay, so if x equals to 2, then the function will be equals to, the function will be equals to what? 0.5 if x equals to 2. Okay, so you can see it here, right? It is 0.5. Then if x equals to 1, then what happened is f of x will become equals to 1 over 1. So you can see it here, right? Correct? Then if x is nearly 0, no. So if x is 0, so f of x will be what? Will be undefined. Okay, so f of x will become undefined. Okay. Okay, I will just check if it is recording. Okay, so which means it will, if we let x closer to 0, so as you can see in the graph, it is going down, until, but it won't touch the 0. So it will just go like this until it will never touch 0. But when it reaches 0, it will, we don't know where it goes. And when we go back to here, we can see here, so it is okay. So yeah, so if we have this one, the other one here, we will have bigger until it goes down. Okay, so you get what I mean. So if we have 1 over 0.5, what happens? It will become 2. 2, am I correct? Okay, we will use our calculator for checking. So 1 divided by 0.5 is equals to 2. Alright, 2. Okay, so it goes here. So if we have 1 over 0.25, it will be 4. Then 1 over 0.10, it will be what? So 1 divided by 0.10 is equals to 10. So you can see it is, as the number goes down, it will be increasing just like this one. Okay, so that's it for the hyperbola. So now we will try to, well, what's happening? We'll try to answer some questions. Okay, question 1. Are you excited to answer some questions? Alright, so we're all excited here. Okay, so we'll print screen that one, then we go here. Okay, what are the vertices of the hyperbola? Vertices of the hyperbola, if x squared over 9 minus y squared over 16 equals to 1. So, okay, brush. Red one, I want the red one, okay. So, as we can see, what will be the A here? A, what will be A? So, wait, oh, so this is not the correct color. Maybe you'll think that this is the right answer, but this is not the correct color. Okay, so it's just like that, okay. So which will be the A here? So A should have the greater diameter, so this will be the A. So A square is equals to 16. Okay, then we will square up that, then boom, then square up that. A should be equals to 4. So as we all know, if there's, so it is a y-axis, so just like that, y-axis. So if A here, this is A, right? This is A. So it is, should be from the center upward will be 4. excuse me. And then downward it will be negative 4. So what happens? it should goes from here to here, then here to there, so it will move the y-axis, so the answer should be B. So let's try to answer B. Wait, wait, wait. Oh, damn it. I forgot. Okay, I forgot about this. I'm wrong with that jury. So this one, I forgot about this hyperbola. Sorry to tell you, but hyperbola. Okay, so which has the minus? It will be the minor axis. Okay, okay, guys. Always remember that. So we learn our mistakes. So everyone made mistakes. Okay, so this one should be the minor axis, and the positive one here, this is positive, right? So this one is positive. This should be the major axis. Okay, so we learned that mistakes the hard way. We failed a question. Okay, so this should be the one we use. So this will be a squared, and this will be the b squared. So a square, so we square up that, it will be 3. So this one is the answer. Oh, so our marriage is done. So 0.2. Oh my god. Too bad. Okay, it's okay. We can do it. So okay, you may print screen this. Sorry, it's not B. Okay, you got it wrong. So 58. So we almost had it. Okay, it's just one step below. Okay, so always remember, guys, that the one who has a negative is the minor axis. Okay, next question, please. Okay, so we can take a revenge. Okay, we will get the revenge we had. So, okay, the one who has minor axis, so this one, vertices, so we will use this one. So, the parabola should look like, the hyperbola should look like this. So, because the positive is the y squared. Okay, so let's see. So what is the square root of 25? It is 5. So this one is 5, this one is 5. So this one should be that, okay, if this is 0, 0, then this one should be 0, negative 5, and 0, positive 5. This one should be B. Alright, see, let's see. Alright, you can see that one now. Okay, so here he was changing again. You can see that he was changing his B. So I don't recommend this changing B because it will damage the other formulas. So just for me, I don't recommend changing that. Okay, so next question. So we got 0.7 merits now. Wait, I forgot to read. Okay, I'll just check if we got a good here. Okay, what are the asymptotes of this hyperbola? Okay. Okay, what are the asymptotes of this hyperbola? Okay, so what will be the asymptotes of that? So as we all know, it should be b over a x, then positive, negative. Okay, so what is the b? So b is 4, then a should be 20. This will be 2, and this will be 5. Okay, we just square up that, okay? We just square up that to get the a and to get the b. Okay, so a should be, b should be 2 over 5x. So what is 2 divided by, so 2 divided by 5 is equals to 0.4. So this one is the answer. A should be the answer. All right, very good, very good, very good. Okay, so next question, please. Okay, we are 48%. Nice. Okay, so here, what are the symptoms? Okay, this one is tricky. If they change this, if they use this as B and this as A, then it will become a more trickier. I think still that which one is bigger should be A, but I don't think they will be using that. Okay, so what should be? Is it still X? Okay, they're still using X, so X equals to what? B over AY. So do you have a copy of here explaining the asymptotes? Okay, here. So if the y-axis is, we will review our answers. Okay, so it should be X equals to B plus Y. So we will just, here, this one, we will just rotate that. Okay, you can see that we will rotate this. I want it 180. Okay, so if that will be the y-axis, then what will go wrong? We choose that as A and that as B. Okay, well, we need to just try that at least. Okay. So what did I do there? Okay. So we will try that. So my B would, for me, this should be A. Okay, I will have a green here. This will be A, and this should be B. Okay. Okay, so I will use my answer. So if this will be wrong, we will use this one. Okay. Okay. So I want to try my answer. So for the rest of you who doesn't know, I just opened this one. I have no idea of what will be the answer of that. Okay, so it depends on the book. So it will be a trial and error run. Okay, so this will be 5 over 3. Okay, so it should be negative 5. Okay, positive negative 5y. So for me, this is the answer. But for the book, this should be the answer. Okay, so let's try that. Okay, I will try my answer. This D. Oh, I'm correct. Okay, so you can see their asymptotes interchange. Yeah, you can see that their asymptotes interchange. Instead of having, okay, we have a drawing here. All right. Okay, so instead of having, you have here, right? Correct. Instead of having y equals to b over ax, they interchange that into a over b. Okay, so for me, still the major axis has a here. This should be a, and the major axis and the minor axis should be b. Okay. Okay, we got that question correctly. Only 45% got it correctly. What is the intrinsic eccentricity of hyperbola? So how round is this hyperbola, man? Okay, so we will get that eccentricity. So we have here, this is the formula. So wait. Okay, I will print screen that. Okay, so the formula of that will be this one. So the formula, never mind, I will just copy that. E is equals to square root of a square plus b square over what? A. Okay, so what would be the a? So this one should be the a square and this one should be the b square. Then equals to square root of what? A square is 16 plus 9 over what is the a square? 4. Okay, you just square root that, so you will get 4. Uh, okay, so this is 16, 9, and this is 4. Okay, this is 4. Okay, so 16 plus 9 equals to square root of 25 over 4 equals to 5 over 4, or it is equal to what? Wait, we got it mistaken. So this should be, okay, good for, oh, it is correct. Oh, it is correct. It is correct. It should be 9, 4. Okay, so 5 divided by 4, we will use our magic calculator. 4 is equals to 1.25. So the answer is C. So let's try C. Yeah. Okay, so you may take a picture then. And 1, 2, 3. Okay, so next question, please. We'll finish this until this one, 10. So we'll move faster. Okay. Okay, so we have here the eccentricity. Okay, so we have this one as A and this one as B. So A square and B square. So we have eccentricity is square root of A square plus B square over A. So we have A square as square root of 25 plus 144 over 5 equals to, okay, we will use now our calculator. 25 plus 144 equals 169. So square root of 169. Okay, I'll make it clearer. 169 over 5 equals to, what is the square root of 169? It is 13 over 5. Okay, do we have 13 over 5? No, so we'll divide 13 divided by 5 is equals to 2.6. So this is the final answer. 2.6, alright. Okay, take a picture. 1, 2, 3. Okay, next question, please. Okay, we'll have that. Okay, what is the length of the latus rectum of the hyperbola? So, as we remember, the length should be in here. 2b squared over a. Okay, so we have that 2 latus rectum is equals to 2b squared over a. Am I correct? Yeah. Okay, so here we have this as a and this as b. So what happens is what? Okay, so we have 2. What is the b square? 64. What is a? So a, this is the a square, this is the b square. So a is square root that 25 square root is equals to 5. Square root of 25 is equals to 5. So 2 times 64 equals to 128 over 5. Okay, so we'll divide this as 128 divided by 5 is equals to 25.6. So this is my final answer. Okay, so the final answer would be this one. So I will just put that. Okay, so that is the final answers. Okay, you may now take a picture. 3, 2, 1. Okay, next question, please. Okay, so print screen. Okay, so what is the length of the latus rectum of there? Okay, so we have LR is equals to what? 2b squared over a. So this will be a, this will be b. So equals to 2 What is the b square? 9. So this is a square. This is b square. 2 times 9 over a. What will be a? So a square 2 is equals to 18 divided by 18 divided by 2 is equals to 18 divided by 2 what? 9. So this will be the final answer. Okay, so here take a picture. 3, 2, 1. Okay, next question. Okay, so following, what is the graph of this hyperbola? Okay, so we all know that the axis of symmetry should be in the x-axis. So this one is correct, this one is correct. Okay, this three is correct. This is not correct, so we will eliminate that. Now we need is the 36. The A. Okay, the A. We need the A. Okay, so we can observe here at B. It is 10, negative 10 here. So this should be 5, this should be 10, then 15, then 20. So he's using 5. So this is the one he used, so it should be wrong. Okay, so this one also is using 5, so this also is wrong. Here we can observe that is not on 5 but is more than 5. And also here it is more than 5, so he's using the 36. So I will choose D. Okay, so you see that? Using the 6. Okay. I don't care about those asymptotes. What do we need to get? Oh, no, but why is he using those asymptotes? Okay. Okay, so that is the final answer. You will just look at the graph. Okay, next question, please. Okay, so is this question number 10? Okay, I think this is question number 10. So in here, so this should be an x. So this is wrong already. So here we have here 16. So we should be using the 4. For this one is wrong. So because it is more than 4. So it is also more than 5 here. It is less than, so this should be correct. Also this one. Okay, so we have 2 of them who could be correct. Okay, so what we will do is we'll find the we could find the B, so we can find the asymptotes of this. If this is correct, so do we have the same asymptotes? So what could be the asymptotes here? Y equals to asymptotes. So let's go back here. Asymptotes. Okay. So this one of we can easily tell if it is just like that or it is more on the like this. Okay, you can see that. Okay, so that's it. So we can know that through the asymptotes. Okay, so y equals to what? B over ax. Y equals to b over ax. So where's that again? Here. We have this one. So we have a y equals to what? B over, okay, over b over ax. Okay, so b is what? We will square up that, we will square up that. So 49 square root is 7. 7 times 7, 49 over 4x. So that should be the 7 over 4. So that should be the slope. So 7 high, and 4 low. Okay, that is the one. Or 7 high, 4 low. Hmm. Mm-hmm. This could be the one because it won't touch that one, right? We have that. It could be just like that. But if you have this, this one is so tricky, right? Right? This one is very tricky. So if we have this 7 here, 7 4, can also do like that. Okay, so proudly to say, guys, I don't know how to answer this one. So we'll just try. So we have all eliminated the wrong ones. So we'll just choose if this one or this one. Okay, so they're both 4. 4, okay. So what's the use of B? So we have no idea because there's no focus. If there was focus, it could be answered. Yeah, it could be answered, but unfortunately there's no focus. So we will get the focus. Could be. If we get the focus over here. Okay, we will just try this one and know the answer. Okay, so this looks more like a parabola. This looks like a sexy lady. So, okay, I'll choose the more parabola. So the sexy lady wins. Okay, so let's see how he gets it. So our vertices was already correct. Yeah, -4 and 4. Okay, so we have here that one. Then asymptotes, how he uses this asymptotes to know that 1.75x and y equals to 1.75x. Okay, so what he did was checking if this one is correct. Okay. I get it now. Okay, so what he did, okay, I will explain to you guys what he did. Okay, so what he did with the asymptotes, we already get the asymptotes right. The 7 over 5x y equals to positive and negative. Okay, so we have it there. So what he did is he want to check if this one and this one is correct. So this should be -10. The x should be -10, and he would like to check if it reaches above 15. Y plus 15. Okay, you get it now. So 7 divided by 5 is equals to 7 divided by 5 is equals to what happened? 7 divided by 5 is equals to 1.4. This should be 1. Why did I have 5? Yeah, why did I have 5? It should be 7 over 4, right? I forgot. Divided by 7 over 4. Yeah, that's what. It should be 7 over 4 because here is the A and this should be the 7 is the B. Okay, B and this is the A. Positive and negative is equals to the asymptote. Okay, so asymptote, okay, y, x, y and the x. So we will substitute x equals to -10. So -10, then 7 divided by 4 is already here. Okay, we will go back. 7 divided by 4 is equals to 1.75. So y equals to negative what? -17.5. So we will just move because we'll just move that one because of this one. Okay, get it? Okay, so 17.5. So it could be here. Yeah, it could be true. So it could be more than 15. So it is considered correct. So if we use the other one, if we use this B, this A, right? This A. So if we use negative 10, it should not reach 15, right? Correct here. Not reach here, but only above 10, but not above 15. Okay, get what I see here? He it is more than 15, right? So this is 10, then this is 15, so it is more than 15. We reach negative 10. Okay, so we have two mistakes in this one. So question number 1 and question number 10. So you got 80% of it goes correct. Okay, so thank you guys for watching and see you guys in the next one. Peace.